Day, good day, guys. Good day. This is Dr. Masalila, and I will try to explain the dynamics so that when you come to my lecture, to my physical lecture, you know what we are talking about. Because of time, we need now to spend most of the time doing equations of physics, because we have realized that our physics one PH112 is a lot of questions. So let us now kill two birds with one stone. Yeah. So make sure that before you come to a lesson, you go online, you watch my video, so that when you during the lesson you just do questions. So dynamics. Why do objects move the way they do? They move the way that they are moving is because of force. What is the force? Force is whereby you pull, you push, or you twist something. That is a force. That is the ideal way force it is. Forces are what cause any change in the velocity of an object. Units of force are Newton. And I want you to go and find dimensions of force. Obvious, force is going to change the velocity. When something is moving, I can just put in my hand like this and that thing stops. You can see that now that is the effect of force. What happens when we push an object? When you push an object does not move. Object change velocity. The person pushing moves in a direction opposite the direction of which is pushing. Obviously, when we push an object, the object is going to change what? The velocity is going to change. So our answer here is going to be this. When we push the object, we can say when you push the object does not move. Yes, sometimes the object does not move when the pushing force is the same as the resultant force. So although all of these conditions, they can apply under some certain condition, but let's assume that our force is great enough. That means that the velocity is going to what? Is going to change. Newton's laws of motion. There are three Newton's laws of motion that you need to understand. The first law is called the law of what? Inertia. The law of inertia. It states that in the absence of external forces, an object remains at rest or continues to move with constant speed in a straight line, that is a constant velocity. The first law says that when the object is at rest, that object is not going to move unless you apply a force on it. Or when an object is moving in a constant velocity, that object is going to continue to move in that constant velocity unless a force is being applied to accelerate it or to decelerate it or to stop it. The second law of motion states that the acceleration of the object is directly proportional to the net force acting on the object and is in the direction of the net force. The second law says that F, the force acting on a mass, is going to cause the acceleration, and this acceleration and the force, they are directly proportional, meaning that if I have an object like this, the object of a mass L, for that object to have acceleration to that direction means that the force acting should act toward that direction also. This is the second law of motion. So this is what you call a vector equation. So when you say that is a vector equation, what does it mean? That the force acting can act in three directions. F can be influenced, the F can be influenced by the forces acting on the horizontal. The F can be influenced by the forces acting on the Y, and also by the forces acting on the Z. Meaning, for you to find force, let's assume that we have a diagram like this and the force is acting this. This is our force. We are going to find what? The x components of this force and the y components in this force. Find the magnitude, and that the magnitude now, y components, sorry, the y components is this side, and find the magnitude. The magnitude now is going to be our what? It's going to be our force. It's going to be our force. Means that for you to say something is a vector, the direction matters, and the direction of our force there is the angle. The direction of our force there is going to be the angle theta. So the angle theta there is going to be the direction of our force. It's going to be the direction of our force. Let's continue with an example. From that example, you can see that we have the force acting. We have what? We can see that we have the force. We have the force acting. This one is F1, and we have the force acting. This is F2. Now we have this force called F3. F3 is a force acting at an angle, meaning that that angle is a direction. We need to separate this force into its y component and into its what? X component. So what do I mean? We are going to have the force acting in the y, and also have the force acting in the what? In the x component. Now the total force, that sign means, the sign there means what? Summations. The summation or the total force, the total force there is going to be, the total force there is going to be what? We are going to take our condense. The total force there is going to be F is going to be F1 plus negative F2 plus F3. That's our force there. That's our force. Or we can take it on the other side, and we say the force acting there is F2 plus F3 minus F1. Let us look at that diagram there. Let's assume that our object is moving in that direction, is our acceleration. Because I get the magnitude, so we can't see which one is greater than the other. So let us assume that the forces in this side are greater. So when the forces of this on this side are greater, it means that when I add the F2 and the F3, I subtract what? F1, because F1 is going on that direction alone. So this one, the reason why I assume that the diagram is going there is because in the Cartesian, this one is positive and this one is negative. So we are going to add F2 and F3. F3 we minus by F1. But we need to know that there are two types of forces in F3 or direction. We have forces which are acting in the x-axis and forces which are acting on the y-axis. So for us to find the summation of the force, we are going to take accountants of two directions, in the x-axis, then in the y-axis. Now, according to that diagram there, we can see that F2 is acting on the x-axis only, and we are going to add it with F3x only, and we say minus Fy, because F1 is also acting in the x-axis. This one for now we are going to eliminate. We are going to eliminate it from, because we are dealing with the x-axis. So we can see now, when we say the summations of the forces which are acting in the y-axis, we have one force acting on the y-axis. We have one force is acting on the y-axis. So from that diagram there, we can see that, because now let's assume that the object is not moving, there's going to be no acceleration. Sometimes Newton's second law given in terms of change in linear momenta in linear momenta. So what is the momentum? Momentum P is equals to m velocity. Now, what is force? We can see that force is equals to mass times acceleration. Force is equals to mass times acceleration, which is, what is our acceleration? Our acceleration is what? Force is equals to mass times acceleration. Now, force is the same as mass. What is acceleration? Acceleration is change in velocity over time. That is our acceleration. That is our acceleration. That is our acceleration. It's change in velocity over what? Over time. Over time. Now, the time rate of change in linear momentum of the object is equal to the net applied force. Is equal to the net applied force. Is equal to the net applied force. Because I say that force is equal to mass times acceleration, which is force is equal to mass times acceleration. Force is equal to mass times acceleration. Again, and we say that acceleration is change in velocity over t. Acceleration is change of velocity over t. Now, look. What is acceleration? Acceleration is change of velocity over t. This side, this side, you see this side only, mass times v is the same as what? Mass times v is same as what? Momentum. I can say that momentum is mass times v, and here we say momentum is mass times v. Again, and we say that force is the same as mass v over t when that we substitute the acceleration. So in other words, we saying that force is the same as momentum. Again, momentum is mass times v over t. That's momentum. So in other words, we can say that force is the same as the rate of change of momentum. The rate of change of momentum is the same as Again, when something is over t is the rate of change. Power is the same as rate of change of work is power. Because I can say power, I say that power is equal to W over t. So conservation of momentum. Conservation of momentum. Conservation of momentum.